IPF, maybe date.unique. It shows me all the unique dates. Then I can identify anything which is out of place. I remember normally unotokarishandisa padata rakasviba, expecting on a gender column unoona kuti yakukubuditsira kuti male female wombona OU wombona D. There are various methods of doing so. Sometimes you try converting it. For instance, in the date column, when I'm working with it, I convert it to a date. So when I convert, there's something inconsistent in the dates, and I dive in for a closer look. So anyway, I guess we will also do a practical of this, of feature engineering in detail. So we will be able to look at how to practically apply some of those things.
Okay, thank you very much.
Okay, so there's what is called aggregating. You remember when we were aggregating, when we were doing EDA, unfortunately, I only looked at the group by function. And now I pivot. But there are times when pivoting works. So when you're aggregating, for instance, in this case, what I hit group by user ID. Yeah, I'm not going to explain it. I record. Group by user ID, then I aggregate number of playbacks, dot count or sum, total time dot sum, then we can have the preferred device. Yeah, which is what you end up funding, but we'll take the appearing instance as more like a mode or something. Now, then we have pivoting. It's necessary when the entity to model is an aggregation for the provided data. Let's assume what I want produced. I want to see, to model using the values for TV on the device. Let's assume model yangu ipinde kuti for this person anenge akashandisa tablet kangani, TV kangani, or a smartphone kangani. I want to create those features. Yet data set redu yarakadai. User and a TV etc. So I can pivot this, then create different columns. You see? Tablet etc. So you can now see which particular device you use the most. Playback device etc. So are we together yet on this? Are we clear?
Not quite. Please say it again. Explain it in maybe using different words.
Okay. Language is different and language language and in terms of kuyikhuluma lapha yiwuthi just joking guys. So what
you may continue, it's fine.
Sometimes the particular feature I want to create features on a column that's already aggregated. For instance, in this data set, we already have device, right? Yeah. So I want to find out, like on average, how long does one play? The playbacks one does using if you the playbacks on a tablet and playbacks on a smartphone. kuti pauri kuplay papake. So tinoona kuti unoplay a particular song, like this is more like song than the genre, the duration, etc. So I want to see kuti for a particular song, where do you play it? On which device do you play it the most? You understand? So we split this column, your Yakanzi device, into multiple columns, where each value then becomes a particular column, and we aggregate along that value. For instance, upper playback, meaning number of times someone played per TV, it's 1. Number of times Yaka player per tablet, it's 2. Number of times Yaka player per smartphone is 3. Then we can even do it with duration, whereby it negative is at the particular song times the duration. So which means can I play twice, if it was a 90-second song, I play once per TV, it's a 90-second, it was like this, etc. So you can now find out on which device does one spend the most amount of time. So that's pivoting, changing this column into the variables in this column into a single column and aggregating along those. Pivoting. I may not answer Sisika.
Yeah, understood. Thank you so much.
Okay. Then we look at numerical features. Yeah, I know some will be asking, can I get my number? Why touch them? To no battery. If it ain't broke, don't fix it. Yeah, but that's not always the case. So usually, numerical features are easy to ingest by mathematical models, but feature engineering, machine learning, is indeed necessary. It can be float count. It's easier to impute missing data for numeric values. The distribution and scale matters to some models, especially deep neural networks. You find scaling really goes a long way in improving the performance of the model. So, datasets containing missing value, often encoded as blanks, nuns, not a number. You remember we talked about that, or other placeholders. Ignoring rows or columns with missing values is possible, but at the price of losing data, which might be valuable. So, data iri rakawanda say, how valuable is it? Before you then choose how to handle it. So, various libraries we can use for imputing and various strategies. So normally I'm going to fire Russian sign, sklearn, and item. One strategy is using the mean. This is a basic approach which most will rush to. But mean average so far. But well, sometimes, especially when it comes to these things, there's no one size fits all. Okay, I'll give you an example. Atora salary kangu kema bond and over mandisa mu group rana Elon Musk, nana Mark Zuckerberg, nana Dangote. Then mutotora o 3 or 4 plus medo tovatango vaisa musemu kupiro. Then pova paita uma missing values pama salary papa. Ngeyangu inenge iri missing. Calculate our average papo. Adotarisa kwa inenge iri. It will not be a true reflection of the situation on the ground. So basically what I'm trying to say is the existence or the presence of outliers has an effect on the mean. Saka sometimes can also impute on a mean, it will not work. We have a median. So the median is now more robust to outliers. Whereby it will okay, half the people earn more than this, half earn less than this. So guys around the median, at least whether panima outliers or not. I think I identify and they do not affect the median. Most frequent value. Can out of 100 vanhu vari mudata set redu 80 vari 24 years. There's a very high chance yekuti wacho ane missing data nayo ane 24 years. So you can use a model, but that is algorithmic bias whereby model yako inogona very particularly biased towards a feature or a category. Saka, it depends on the situation, that's all I'm trying to say when it comes to strategies. Saka, am I making sense?
Yes.
Guys?
So,
Yes.
Okay. Strategy equals to mean about, I can put strategy equals to mod.
Yes.
Okay.
Now, tiri papo yedu. Okay, looking at the slide rarakutari. For instance, scikit-learn Nicesina imputer. This was deprecated. Pane not a simple imputer. And the syntax is slightly different. So I'll wake up a notebook, Ratino and that through together using nothing but the latest technologies and libraries for you guys. Right. So this Tomboti is now deprecated because some of the stuff here it won't run. Which totanga ku import up and of yaramba. So another item we look at in feature engineering. So we have missing values. Then sometimes we have what do you call it? Rounding of values. Rounding of values. All right. So rounding, it's a form of loss compression. It's used to retain the most significant features. Sometimes tumakoma unozongoona kuti hai yangovewo noisy. So rounded variables can be treated as categorical variables. Whereby kana taona kuti zvinhu zviri kurenja 0.1, 0.2223, 0.22234. When you round, the uniqueness in data set inodzikira, and you can even then use those values and a less variability as categorical value. For instance, trying to change the confidence panap 10, 1, 2, 5, 4. It means kuti ya range from all these numbers apa ukaisa 3 nongotsoka iri pa 10. Saka it then becomes from 1 to 10. We now have a maximum of 0 to 10, 11 different variables atinogona kuisa ipapa. As opposed kana tikasiya ari makoma anenge akawanda. So this can be used as categorical. Binarization. So we are transforming discrete or continuous numeric values into binary features. For example, user views of the same document. So, what happens is x is equals to 1, 1, 2, 2, 0, 0, 0, 1, minus 1. Binarizer threshold 1.0. Transform. So it then changes into those numeric values into binary features. So katinenge 1 or 0, 0 or 1. That's how binarization works. Into a binary format. We have binning, that's splitting numerical values into bins and encode with the bin ID. Can be set arbitrarily or based on distribution. So
hi Don, sorry to disturb you.
You can have fixed binning.
Hi Don.
Yes.
May you kindly go to the previous slide? Yes, I want to know cases where we can turn our data into binary. Because as far as I'm concerned, it seems like two inputs will look like will be assumed that they are the same. For example, the first column we've got 1, 2, 0, and we now have 1, 1, and 0. So in what cases can we turn our data into binary?
Okay, for instance, I'm not particularly, let's say I'm not worried about the number of views someone has.
Okay.
I'm just interested in knowing whether a page or not.
Okay.
That's then an outcome. So you can now find viewed, 1 being true and 0 being false.
Okay. That I understand. What about on the user IDs? Is like the UUID? What is
the what?
Is it the user ID? Like the UUID?
Oh, unique user. I think it's a unique user ID.
Yes.
So inabasa is affect the binary.
Or unique user ID, because now we assuming that two people have the same ID.
No, we do not apply it on user ID. Normally, when you're working on predictive models, unique instances we try to avoid. For instance, andishandisi model yangu ndichilota customer account number. Reason being, mangwana nchavura a new account number, and that account number is not recognized by the model. Ndoda kuti ive able to identify what kind of a customer based on certain behaviors, based on patterns, without the account number. Meaning kuti pakauya a new customer ndomvurira a new account number, mapattern ake wayo ndandongofita model and inenge echindipredictira. So in this case, unique user ID and a document ID, vanenge vasiri customer model. Chichapinda will be either views count or the fact whether they viewed or not.
Okay.
All right. So split numerical values into bins and encode with the bin ID. And encode with the bin ID. Saka iyo is binning. Okay, sorry guys. Okay. That was a tower. We can continue. Sorry about that, guys. So, split, well, when we have binning, we're just sort of like splitting numerical values into bins and encoding with the bin ID. Can be set arbitrarily or based on distribution. Views made by user, 5 etc. User count, quantile binning, whereby you are binning based on my quantile zero, whether it's the 25 percentile. I divide 25 percentile median, 75 percentile max, minimum. Look at 4 categories.
Said Don, we have lost you again.
Wogadzira wako tumabins twako twecategory yekuti vanhu vane age range yakati mayouth young adults adults chaiwo then retired cannot old more mature people. Hello. I thought kuti ndandakatwa futi. So that would be binning. Kungo aisa into categories, then assigning a unique ID to each category. That's, yeah, I'm guessing the simple explanation. Then log transformation. So what log transformation does is it compresses the range of the large numbers and expands the range of the small numbers. The larger the x, the number, the slower the log x increments. That's what log transformation does to your data set. So you see, upper where it was 1, 0.69, pangeri 5, 1.79. As if on enda uku, 1,500, you see 6.9 and 6.2, 5.7, etc. So it compresses the range so that the feature space in machine learning model yako becomes smaller, and it then becomes more, the model becomes more accurate. and computes faster. So, log transformation, smoothing the long-tailed data with the log. You see how it is? The range, 1,000, then to So as the definition suggested, the small values, it increases their increments. The big values lessens them, such that it then smoothens the distribution. It did not change it much, but it then compresses it into a more understandable range. So, models that are smooth functions of input features are sensitive to the scale of the input. For instance, linear regression. So this is normally used when you are developing linear regression models. So scaling the data into a certain range really works. However, you have to take note of scaling does not affect the feature distribution. So there are two types of scaling. Min-max scaling normally works between 0 and 1. Then we have the normalized scaling or the standard set scaling. So min-max scalar and in a formula E, whereby tributi x minus the minimum of x divided by the maximum of x minus the minimum of x. Right. So x, if our x is the minimum, it then becomes 0. If our x is the maximum, maximum minus minimum over maximum minus minimum, it becomes 1. So that the range then becomes 0 to 1. And yes, this is the syntax for the min-max scale. Here in Akuchinja. We have the z-scalar. Z-scalar in a range from around -1 to 1. So after standardization, a feature is a mean of 0 and a variance of 1, which is normally the assumption of many learning algorithms. So it scales from -1 to 1. Right, so this is the z-scalar, whereby you remember when you're calculating z statistical analysis, it's a formula that looks kind of like this. X minus the mean over the variance. That's z scaling. So another feature engineering technique is normalization. So normalization scales individual samples or rows to have a unit vector by dividing values by the L2 norm, which are Euclidean norm. Useful for quadratic form like dot products or any other kernel to quantify similarity of pairs. Normalized vector. So this is used in text classification and clustering. I'm guessing we'll look at a text feature engineering for text, but so this is the syntax. You take it from sklearner.preprocessing, you import normalize, then you normalize X, you choose which norm you want. Is that the Euclidean distance L2 or the Manhattan distance, etc. So, we have interaction features. So simple linear models use a linear combination of the individual input to predict the outcome Y. An easy way to increase the complexity of the linear model is to create feature combinations, nonlinear features. The degree to interaction of features, polynomial features, right. We also have issues on categorical features. So when we deal with categorical features, they usually need some treatment. One, most models I know, they need a numeric input. So we have to encode these categorical features into a numeric data type. We have high cardinality can create very sparse data. They are difficult to impute missing values. Right. So one way of dealing with categorical features is one-hot encoding. So what one-hot encoding does, for instance, can you see this? Which platform is one using? A desktop, a mobile? A desktop or a tablet? So what happens is when you one-hot encode, it returns sort of like a binary output for each particular category. For instance, if something is a desktop, it inputs a 1. If something is a desktop, it inputs 1. If something is not a desktop, it inputs 0. The same applies here. So in the end, our output would be, if it's desktop, it becomes 1, 0, 0. If it's mobile, it becomes 0, 1, 0. That would then become the representation of each categorical variable. If it's a tablet, it's a 0, 0, 1. This is one-hot encoding. First year, it was a desktop, 1. Then it's not a mobile, it's not a tablet. Second was a mobile, so 0 on desktop, 1 on mobile, 0 on tablet. This was a tablet, so 0 on desktop, 0 on mobile, 1 on tablet. Is it understandable?
Very much.
Okay. One-hot encoding data, there we go. Right, one-hot encoding. So we have what is called feature hashing. So it hashes categorical values into vectors with a fixed length. It offers a lower sparsity than and higher compression compared to one-hot encoding. what is unique about it is its ability to deal with new and rare categorical values, new user agents. However, it may introduce collisions. For instance, here we have Venezuela, Colombia, so that's the future collisions which were being talked about. So this is the code for feature hashing. I'm guessing we just go through the theory, then the practical aspect go on, right?
Sorry to get you on the feature coding, especially on your example for Venezuela.
Oh yeah, you remember what was happening with one hot encoding?
Yes, I understood very well the one hot encoding.
Yes. So country hashed one. This is hashing. So Brazil, it's more like one hot encoding, but it's sort of like compresses. Each item is meant to have its own hash.
Okay, so you're saying Brazil will take country hash 1, then Chile will take country hash 2, Venezuela should take country hash 3, and so forth.
That's how one hot encoding would work. But feature hashing, it does it using a particular algorithm, such that, you see, it did not take country hashing 1. It went for country hashed 4. Then what we were talking about may introduce future collisions is Venezuela is on country hashed 3 and Colombia is also on country hashed 3.
Oh, that's probably okay. Thank you.
Okay. So, bean counting. Instead of actual category, yeah?
Then how do we deal with the collision?
If you're afraid, you fear for the collision, you can go for another way of handling the categorical variables. You can use one hot encoding or label encoder. If you fear there is a possibility, yeah. Up until essay, then you then choose the one you're going to decide which is depending on the particular instance you're going to.
Hello, Sedon.
Yes.
You know, most people are just quiet. They don't even understand why we are doing these things. Are we going to be using these things when we are doing the actual feature machine learning model? And
yes.
And then tichizoshandisa zvinhu izvozvizvi zvatiri kutaura izvozvizvi kuti model yacho ibude zvakanaka, because some of these things patiri dzatonyu Greek chaidzo.
Yeah, that's why ndati ndotanga ndaenda nemi through this tichitarisa the underlying theories. Saka I know kuti most of it might not make sense. Asi patichazoti tichidependa noti tapedza nguva mangwana kana kuti nhasi later tinogona kubva tachizopindira a notebook takuchizviapply tichitarisa how it works, the instances in which it works, tichivaita model. Now pamuri kuzotanga deep learning models uchaona kuti inongopinda data riri numeric. Kuimprove performance kuchada kuti uscale. So when you understand how it works first, then we can then apply it practically. muchizoona kuti oh yeah, that's why tanga tichimbotaura zve-one hot encoding. That's why we talked about this, etc. It's sort of like, for instance, categorical values. Let's assume I'm trying to predict data rakawanda. Ndoda kuzopredicta kuti saka chakati munhu chinhu changa chishandisa chi. Was it a desktop, a mobile, or a tablet? Ndoda kuisa y wangu. I cannot put y as my strings I have to change that y into a format that can be understood by the machine learning model, which will be something like this. For instance, Natok Maka activation functions. Ana softmax anani sigmoid etc. Did you look at those when you were doing machine learning mathematics? Guys,
I don't remember those ones.
I don't remember hearing those words.
New stuff.
All right, fine, but how softmax work would be. And under each predictor is, I present it kwazviri yakadai. Each ano is a probability, the probability this is a desktop is E, probability is a mobile, probability is a tablet. Then what it then returns to me becomes the index of the item with the highest probability. Saka inenge ichazondiudza kuti chi yakapredicta desktop and predictira 0 etc. Then ndobva ndachinja that format back to iyo. Then I'm now able kuita sei kuona kuti what its predictions were. So if I am to feed a multi-classification variable into a deep neural network, ndichashandisa a function in softmax, and softmax inenge ichida iri in this format. Iyo yozondireturnera chiti whether it was 0, which would be here, 1 or 2 panapa. Then kana ndakuzobuild a confusion matrix ndichazvichinja zvochiita something like this, and tinenge takuona which items were correctly predicted and whatnot. But do not worry, we'll be covering the practical aspect of these things.
Thank you, because some of us were already drowning.
Okay. I know. Label count encoding. So this one, is a number, a unique number for each label. For instance, this is 1, this is 2, this is 3, etc. That's a label count encoding. It does not give the same encoding to different variables. Each one is unique. So inozongorwadzira kuti kana une 100 categories unozosvika up to 100. Paunozoisa machine learning model, there is a challenge yekuti inogona kufungira kuti a feature in a value 100 is of more importance than a feature in a value 1. Muri kupabata? Kuti model yako inogona kufunga 5 is higher than 1. Yet these are nominal variables, which is why pakazouya one hot encoding yekuti it will be either a 0 or 1. We have category embedding. Less memory overhead can give better accuracy. Okay, my embedding. Kana tikazobuilda LSTM models, we will look into this. Kugadzira those embeddings. So, besides, we have numeric features and atinogona kuita feature engineering. We have categorical variables. Then we have temporal features. Temporal, we're looking at time. a time aspect. We can convert time zone conversion. Tino dates. So we can change, data really in time ye uko ku UK to change ita time ye mono. When it comes to time, model kashoma kuti ipinde time direct. So you can now pin it, put all right. If it's between 5 and 8, it's early morning, etc. We can create categories with it. No time pinning actually. So trend lines, instead of encoding total spend, encode things like spend in the last week, spend in the last month, spend in the last year. So what they're just saying is, to change your data redo, aggregated weekly, monthly, annually. Then to chitanga ku monitor my trends, for now whether it was increasing or decreasing. Closeness to major events. Hard coding categorical features from dates, proximity to major events. Yes? Oh yeah. So on time one, I remember when I was working on a segmentation model, I used the time variable with some clustering model, but I had to change it. Nagatora the number of days since last purchase. That's a method of temporal, working with temporal data, temporal feature engineering. Time differences, spatial features in the OIA date time. There was a model we once worked on. I noticed kuti yaiva nema coordinates mukati. So for the model, I had to work on an algorithm yekuti it would change those coordinates to points and calculate the distance between points. Saka mu model mangama kupinda distance instead of the particular points. Textual data. When it comes to textual data, we have and clean. Then when people write, for instance, data in a province, chetunozotu Zimbabwe mune 10 provinces. Saka pa 10 provinces, mumano kononyora Mashonaland East achitangane small m. Mumano kono kushansa big M. Mumano kono after at Mashonaland East of Isa space. Mumano kona kuti Mashon ogerekera kuisa A. Shonaland. Shidaro. Saka all that is something you then look at. For instance, can I teach the issue of my case in engage affect data rako? You can just use lowercase on the entire thing. You now have some form of consistency. Yeah. Let's assume you are working with IDs. Pamwano nyora ID is 08-4433-A-71. Then mumwano gwenyora yakabatana. Mumwano is a space instead of my dash. So those inconsistencies are what you'll be looking at. Saka, when it comes to text, we have, I'll just do a quick rundown. Cleaning, which is removing lowercasing, removing non-alphanumeric. This includes punctuation, etc. We have tokenizing. Tokenizing is when you change a sentence in a text into a list of words. each word in the sentence becomes a token. Each word in that string of text inenja a token, no tokenization. N-grams, yakugroupa my words. If it's 2 grams, irungo groupa my words 2, each katsira ma token akadaro. Removing. If you are going to be doing a sentiment analysis model, there are certain words a model would assume akakosha kudarika mamu, would incorrectly give higher importance to because they appear many times. Iwayanons must stop words. In any sentence, someone is going to use things like the, is, of, a. So those become the most appearing words in our text document. So those need to be removed on keywords which are capable of giving us the insights we want. Routing, roots were spelling correction, chop, stem. Stemming is kusarane a root of a word. So when we're looking at stemming, we can look at, every morning I run, I like running. Model Pino vectorizer those, it will assume run and running are different words altogether. However, if I stem my words, inongosara ka root, ka run. So run and running become one word. So I know this was still talking about the same thing. Your reduce of variability in your text and your model can perform better. Enrich, entity insertion or extraction. Yes, pane yavanoti name entity recognition. Whereby wakayisa yoyo and you apply it to text. Inenge yakuto identify kuti this is a name, this is a global political entity, a country. This is a place, this is a city, etc. So if your text is such text, the model understands the text easier than text yet no. So, having done issues, we can then go for text vectorization. So what text vectorization simply means is it's assigning numeric values to text, right? So we have bag of words. You know, go assign my unique values arbitrarily. Then we have what is called TF-IDF, which stands for term frequency. That is the number of times a particular word appears. Inverse document frequency. Yeah, appears in that block of text and appears in the entire document. So, what we are talking about would be bag of words, term document matrix, Linux in document 1 appeared 3 times, 4 times, etc. Modern 4, 3, something like this. That's a document term matrix. So Linux in document 1, Linux can then be presented as 3410. Modern is 4301. So apese pa chapia modern nenge chisa this numeric value. Then
John?
Yes?
I want to ask something still on that. Do partitions are library NLTK or
NLTK? Yes, NLTK nation is it's a ish. Text vectorizer tokona iwana ku scikit-learn.
Okay.
Then NLTK is capable of tokenization, an entity insertion or extraction, stemming, lemmatization, tokenization, zvinenge zvichiitwa neNLTK, the Natural Language Toolkit.
Okay.
So, back of words and maona kuti inongoverenga kuti mawords apia kangani, then yobva yangoassigna each word a particular value. Saka pana Linux inenge ichiisa 3410 etc. Saka yakuchiti pa text yako, instead yokupresenta Linux modern the system, inenge yangove nezvima values izvi. Ndo zvatakufita in our model. However, a way inoningirikina, most then favor yavanoti TF-IDF. The difference then with TF-IDF is it assigns weight to the document. So relevant terms in a document are frequent terms in the document and rare in other documents. Meaning that if a term appears the most in one document, it means that it has a degree of importance. So document 1, Sagayakuchi assign these weights to the words. That's TF-IDF, and this is its formula, whereby we look at the weights assigned using the frequency of the term in the document divided by the maximum number of times the feature appears in all the other documents. Then that becomes the weight of the word. That's the term frequency part. Then IDF, it then becomes the log of the total number of documents over the number of documents that mention that particular term. Cosine similarity. Cosine similarity painoshanda. It's developing chatbots. So when we're developing a chatbot, right, we vectorize our words, and then our vectorize, we then map my frequently asked questions in. But okay, users normally ask this. So what is the price for a laptop? Is there a payment plan? Is there what? Then we give answers. However, in the real world, users kuzovunza what is the price of a laptop? User no gonna put what are your laptop prices? So what cosine similarity does, it then looks at question your user. Which question does it most closely represent? Frequently asked questions. Then you return the output, the answer to that question. Kuti iri kufananidzwa kuti a question iyi yakanyanya kufanana ne-E. Saka answer iri kuda munhu uyu nde-E. That's cosine similarity. Okay. The other similarities are token, counting the number of tokens that appear. Then we have cosine similarity between two word embedded vectors. Topic modeling. Feature selection. So feature selection is which particular features will we use per model yedu. Data redu rinogona kuya rine macolumn 154. But pa macolumn 154 ndeape akakosha ekushandisa. So we can, by selecting my features, we reduce model complexity and training time. If it has fewer features, it trains fast. So we have filtering, whereby to notice the correlation between our feature and the target variable. Tapedza kudaro tobva taita sei? Tabvisa those variables which are not related to the target variable, right? We have REPA methods. It uses expensive, tries to optimize the best subset of features. So, feature selection as part of model training process, e.g. feature importances, whereby kana ukashandisa a decision tree, you can visualize kuona kuti ndapi ma-features angachiratidza kukosha kwawo. Then E, it uses a mathematical formula to just calculate which features are important. And the more data beats clever algorithms, but better data beats more data. That's the rule for feature engineering. A diverse set of features and models lead to different results. Baseline. So, what you can do, two approaches, okay, apa vakashandisa ensembling. Oh, these were the models. Oh yeah, approach one. These were the models, gradient boosts. Gradient boosted decision tree, towards automated feature engineering. Oh yeah. So, yeah, with deep learning, how it then engineers the features, shandisa feed-forward networks and big propagation. So yakaenda ukuya adjusta ma-weights unoona answer yodzosera, output yo adjusta futi ichidzokera. Saka feature inenge isina basa in the end, inenge isisa adjust. Saka the weights will then be related to the feature importance. Yeah, so this is all we have on the slide. Would you like us to start the practical today, kana kuti toisimudza mangwana?
Ngatite mangwana.
Mangwana bro.
Mangwana.
Aiwa, nhasi kuita semangwana.
Ngatite mangwana.
Tomorrow.
Mangwana.
Okay, Saka, I guess the principle of democracy dictates kuti topa taisimudzira mangwana. So ndichango prepare a notebook, rancha uploader, then tofamba tese doing some of the feature engineering methods dzatataura nezvadzo.
Thank you. Thank you very
guys.
Thank you, sir.
Don?
Yes.
Wanted to understand how far have you gone with the machine learning? Do you have some applications that are in production that are being used by my customers and clients?
Repeat the question.
Like I understand you are with CBZ and I'm one of the customers for CBZ. So I wanted to ask you, are there any machine learning projects at all in production are kushanda so far?
Yes, Aripwao. Unfortunately, I cannot divulge them, but
of course, for this module. Is there anything which we need to download? Is there anything which we need to download?
Oh, you'll be using your Jupyter notebooks and Python libraries.
Okay.
So I'm guessing when we get to a particular point, models, when you're about to start the deep neural network models, well, you'll just be adding by using your Anaconda yenyoyo. Mongo etera libraries such as TensorFlow, which is, but then most of them, I think Makarami now, Anapandas and Anampy, Nana Scikit-learn.
Okay, thank you.
All right.
Yeah, I just wanted to check if the class managed to do my assignment. Yesterday I couldn't join you.